there are two special triangles that you learn about in this class. The first is a 45-45-90 triangle, and the second is a 30-60-90 triangle. And this is the one that we will be learning about today. So, in a 45-45-90 triangle, we started with a square that had 90-degree angles here and here, and all congruent sides. We then drew a diagonal here, and we found that this side, this angle became 45, this angle became 45, this angle became 45, and this angle became 45. We then found what makes these triangles special is that the angles and the sides had a unique relationship. The 45 was always across from the side labeled X, and the 45-degree angle was always across from the side labeled X over here. So how do we find this side here? We did Pythagorean theorem, and we got X square root of 2. So that was the 45-45-90 triangle. And today we're learning about the 30-60-90. So the 45-45-90 triangle, started with a square, we drew a diagonal, and that's where the two triangles came from. The 30-60-90 triangle, however, starts with an equilateral triangle. So this side here is 2x, which is congruent to this side here, 2x, and the bottom here is 2x. Each angle measures 60 degrees, as it does in all equilateral triangles, and we start with that. Then we draw an altitude here. An altitude in an equilateral triangle bisects this angle here into two 30-degree angles. It forms two 90-degree angles down here, and it bisects this base down here. So this is where the two triangles in a 30-60-90 special triangle come from. This triangle here, this equilateral triangle, splits into this triangle here and this triangle here. So we know that this side here is 2x because this side here was 2x on the equilateral triangle, and it has not changed. We know that this side here is x because this side here was x on the equilateral triangle, and that has not changed. What if we didn't know this side here, though? How could we possibly find it? We would use the Pythagorean theorem just like we did in the 45-45-90 triangles. So, we always want to find C first. C is always across from the 90-degree angle, so C in this case would be 2x squared equals, this one here is A, this one here, is C, this one here is the unknown. So we get 2x squared equals x squared plus b squared. So we solve here, we get 4x squared equals x squared plus b squared. Subtract x squared to here, subtract x squared here. We get b squared equals 3x squared. Square root, I get b equals x square root of 3. And that's what this is here, right? So let's work off of this triangle that doesn't have everything written on it. In the 45-45-90 triangles, we used x as our variable, right? So this was the triangle here, this was x, this was x, this was x square root of 2. Just to distinguish between the 45-45-90 triangle and the 30-60-90, we're just going to use y as the variable now instead for 30-60-90s. And this right here is the relationship. y is always going to be across from the 30-degree angle, y square root of 3 is always going to be across from the 60-degree angle, and 2y is always going to be across from the 90-degree angle. Let's do a practice problem. So first, we're going to use our guide triangle. So we fill out all of the angles in the triangle. We match up the sides to the angles. So the side across from 90 is 2y, the side across from 30 is y, and the side across from 60 is y square root of 3. I then use these values and put them on the corresponding parts on the figure. So this side here is y. I say this equals y. This side here is y square root of 3. I say this equals y square root of 3. This side here is 2y. I say y equals 2y. Now, I let the figure speak to me. Do I see the number anywhere that the figure gives me? Yeah, it gives me 8 right here. And look, it says 8 equals y. So now I know everywhere in the figure I can substitute 8 for y. This side here becomes 8 square root of 3. This side here becomes 16. And this side here becomes 8. So if I need to find x, now I look on the figure, I find x here. So x is 8 square root of 3. I look for y. Y is here, so y is 16. Okay. Let's do this example here. I use my guide triangle. This is 90. 90 is across from 2y. Y is across from 30. Y square root of 3 is across from 60. I put these values into the figure. This side here is 2y. This side here is y. And this side here equals y square root of 3. Next step is I find the number that the problem gives me. They give it to me right here. That is my equation that I use. I get 15 equals y square root of 3. Divide by square root of 3. I get 15 over the square root of 3. Now, I cannot leave this square root of 3 in the denominator here. So I have to rationalize the denominator and multiply the numerator and the denominator by the square root of 3. I now have 15 square root of 3 over 3. 5 square root of 3 equals y. I now put this value into the equation everywhere I see y. This side becomes 2 times 5 square root of 3, or 10 square root of 3. This side becomes 5 square root of 3, and this side remains 15 as they gave it to me. Now I solve. Find x. X is here. It's on the side that's 5 square root of 3. X equals 5 square root of 3. Let's do one more example here. I start with my guide triangle. 90 here. Side across from 90 is 2y. 60. Side across from 60 is y square root of 3. 30 here. The side across from 30 is y. I put these values onto the figure. I get 15 equals 2y. X equals y square root of 3. And y equals y right here. This is 60. Okay. Now, the second step is I look for the number. That becomes my equation to solve. I get 15 equals 2y. Divide by 2. Y equals 7.5. I now put 7.5 for y in 7.5 square root of 3. I get 7.5. X, they tell me to find x. X is here. X equals 7.5 square root of 3. Now, let's try 2 challenge problems. Look at this one here. It says the perimeter of an equilateral triangle. Actually, you know what? We're going to do this in the next video, okay? This video is going to be finished.